Mr. Powers. This is Carlos Rodriguez Delgado, and this is my C++ final, part 2. I want to keep this explanation simple and beginner friendly, just in case I need to ever use this final project to review these topics. And let's dive right into it. Today I'm going to explain what smart pointers are in C++. But I think first we need to understand what a normal pointer is, which is a pointer stores the memory address of another variable or object. Pointers are powerful, but I know that they can also create problems if memory is not managed correctly. One of the biggest problems is memory leaks. A memory leak happens when memory is allocated but never properly released. This wastes the memory and can eventually slow down or crash your program. Smart pointers were created to help solve this problem automatically. Instead of manually managing memory ourselves, smart pointers automatically clean up memory when it's no longer needed. Today, I'm going to explain what regular pointers do, the problems that they can cause, and what smart pointers are, and how smart pointers help make programs safer. Then I'll compare a regular pointer example with a smart pointer example. So I just want to point out over here into our header files, right here at the top of the program, which is our first include statement is iostream, which allows us to print output using cout. The second include statement, it's going to be over here memory, which this is very important because it gives us access to smart pointers in C++. And then over here, down here, we have a library. Without this library, we would not be able to use things like the unique underscore like PTR. And of course, we have easy namespace std, which lets us write cout, and unique underscore PTR without writing std every time. And now I want to point to our first class called dog. This is a simple class that we use for this example. And of course, the class has a constructor, a deconstructor, and a function called bark. The constructor runs when the project is created, and the deconstructor runs when the object is destroyed. Here, pointing at the constructor, when a dog object is created, the message prints dog created. This helps us see exactly when the object is made in memory. And over here, this is the deconstructor, which runs automatically when the object is removed from memory. When that happens, the following message prints, which is dog destroyed. This is important because it helps us see when memory is cleaned up. And then over here, this is the function called bark. When this function is called, the dog prints woof. This function is simple on purpose because we want to see the main goal of this presentation is to understand, of course, pointers and memory management. And then if we go down here to our main function, this is where the program begins running. And then this is going to be our title of the program, which is regular pointer example. First, the title is printed, which separates the first example from the smart pointer example later. First, now we create the regular pointer, which this line is very important, line 29. You can see right here, because first we have dog times, which means dog1 is a pointer to a dog object. And then when we have, and then we use new dog, which the keyword new creates an object and dynamic memory. Dynamic memory is the one that stays allocated until we manually remove it. So this line creates a dog object and it stores its memory address inside of the pointer dog1. When the object is created, the constructor runs. So the thing that we should see on the output would be dog created printed on the screen. And over here in this in line 31, if we can see right there, now that's the error operator, which means that now we call bark function using the pointer. And since dog1 is a pointer, we use the error operator instead of a normal dot operator. This helps us tell the program to access the object through the pointer, so this line calls the bark function and the output becomes woof. And then in line 33, where we have delete dog1, this line is extremely important because remember earlier when I said that dynamic memory must be cleaned up manually? That is exactly what happens here. The keyword right here is going to be delete, which removes the object from memory when the object is deleted. The deconstructor runs automatically, so we should see dog destroyed printed on the screen. One of the things that I also wanted to get into is I wanted to talk about and explain a little bit more about the memory leaks. So let's say, for example, imagine if you forgot to write delete dog1, then the memory would stay allocated even after the program no longer needs it. Which this would eventually create a memory leak. And memory leaks are dangerous because they waste memory. In large programs, memory leaks can eventually slow down the system or also crash the application. This is one of the reasons why smart pointers are useful, because they help us prevent these mistakes automatically. And right here, pointing at my second title, which is Smart Pointer Example. In which this is exactly what the Smart Pointer is, line 39. That's what that line creates the Smart Pointer. Specifically, it creates a unique underscore PTR, which is the smart pointer that owns one object. This is really an important thing because about a smart pointer, because is that it automatically cleans up memory when it is no longer needed. So unlike the regular pointer example, we do not need to manually write delete. The smart pointer handles that automatically. Now let's break this line into parts. Unique underscore PTR dog means dog2, which is a smart pointer that manages a dog object. Then we use make unique dog. This creates the dog object safely and returns the smart pointer. This is recommended and for example, modern C++ ways to create smart pointers. And right over here in line 41, it's just like before. We use the error operator to call the bark function. So the dog prints woof. And then right here in line 43, and just return 0, it's something that I want to know that it's important that happens automatically is that when the program reaches the end of main, the smart pointer goes out of scope, which means that the smart pointer is automatically destroyed. When the smart pointer is destroyed, it automatically also deletes the dog object, so the destructure runs automatically. This means that we do not manually write, the smart pointer just handles. Um, sorry, what I wanted to say is that we do not need to manually write delete doc2, which see we don't have delete doc2 in this case because the smart pointer handles all of that for us. Moving on, this is one of the main advantages of smart pointers, which is that they automatically manage memory and reduce the change of memory leaks. Now, I'm going to run the program so we can see the output. Right here in the output, first we see dog created. That happens when the object was constructed. Then we see woof. That happens when the bark function is called. Then we see, of course, dog destroyed, which happens when the object is deleted. In the regular pointer example, we had to manually write delete doc1. But in the smart pointer example, the smart pointer handled that automatically without having to write that. That is why smart pointers are safer to use and easier to manage. And just to give a quick summary of everything, um, a pointer stores the memory address of another object, and regular pointers require manual memory management. And when we use, for example, new, we usually need to use delete. If we forget to delete that memory, we create a memory leak. Smart pointers help solve this problem automatically, like I said before, and the smart pointer automatically destroys the object when it is no longer needed. And in this program, we used unique PTR, which is one of the most common smart pointers in just in the modern use of C++. And the smart pointer automatically cleaned up the memory for us, which makes this program safer and reduces bugs caused by memory leaks. And I think finally that smart pointers are very important in the modern use of C++ programming because they make memory management easier and more reliable. Thank you for watching.